Good afternoon. My name is Jordan Skoll. I'm the product marketing specialist at ActiveCampaign, and I am a self-taught developer and a hobby tinkerer on IoT projects. Today we're going to be learning how to connect some IoT projects to a third-party CRM, ActiveCampaign, using Amazon Web Services, AWS Lambda, API Gateway, and serverless. So let's take a closer look at what we're gonna build. So we're gonna flash a light on a physical device using Particle Photon when a deal is won in ActiveCampaign. And we're gonna build this by using serverless to send data through AWS Lambda, and serverless is gonna act like the glue to let us get this all built in under 40 minutes. We have a lot to cover, so I'm gonna try and move pretty quickly here. So what is AWS Lambda? It's an event-driven serverless computing platform, or it is a compute service that runs code in response to events and automatically manages the compute resources required by that code. So what that means is no servers. It's kind of like a function as a service, if you want to think of it that way. So you can scale it up or down. So if you have if you're not doing any compute, then you're not using any resources and it costs you $0. And then you can scale that up infinitely, and AWS will handle the scaling infrastructure for you. And you only pay per 100 milliseconds that your app is actually doing work. API Gateway is another Amazon AWS product, and it makes it a fully managed service. It makes it really, really easy to create, publish, maintain, monitor, and secure APIs at any scale. You can do things like export SDKs, Swagger files. It's really pretty sweet. And serverless is a framework and command line tool that allows us to build and deploy auto-scaling pay-per-execution event-driven function. So basically it lets us connect API Gateway and Lambda together to build our function as a server. And we're going to be using Particle.io for some of the fun part of this this lesson. Particle.io is it's a set of devices. I think 3 or 4 devices will be using a Particle Photon. It is built on the Arduino platform. It uses very similar language, C++. It's very easy to learn, and it's very easy to get your devices connected to the cloud. So that's how we'll be able to actually route requests through our app to Particle. So basically our app, what it will do is it will transform the payload into something that Particle needs, and we'll use that to flash the light and listen for the event in ActiveCampaign via webhook, and that's how we'll build it. So ActiveCampaign, we'll get an ActiveCampaign webhook. ActiveCampaign will send a webhook when a deal is marked as won. That will hit API Gateway, and API Gateway will then inform AWS Lambda to do some work. AWS Lambda will transform the request and then send another post request on to Particle telling us to flash the light. And this is what it would look like if we were closing so many deals that we couldn't handle it. AWS Lambda would just scale horizontally in order to accommodate as many requests as we needed. So if I wanted to build an app where not just one of our internal deals was marked as won, but any deal anywhere was marked as won, well, the light would be flashing an awful lot, but the code infrastructure would be able to handle it. So the prereqs that I'm not going to be covering, you can read about these in the serverless docs, is I'm going to start with serverless installed. Serverless depends on Node and NPM, and you just install that globally via npm install g serverless. And then I also need the AWS command line tools. Those are handled pip install AWS command line. And I'm also not going to cover exposing any of the AWS keys. There's several ways that you can tell serverless about your AWS credentials. The way that I have it set up is I have a profile called serverless admin that I keep in my personal folder .aws/credentials, and it's pretty easy to configure and to drop that in there. So you can read about this on the serverless docs, serverless website, but it's not too hard to get set up, and you only have to get it set up one time. Here's a video I've included from the serverless website that talks about how to configure your credentials. Okay, so nobody likes to look at slides. Let's actually dive in here and build an app. So let me actually start with a fresh terminal install here for you. I'm going to cd into my sites directory. And the first thing I'm going to do is I'm going to run the serverless command without any arguments so we can see what kind of stuff we can do. So serverless has a bunch of different things, commands installed that we can use. We're going to use create, that first one, serverless create new instance, and I'm going to pass in a few arguments just to help us get up to speed. This follows along very closely with their getting started documentation. So I'm going to say serverless create template AWS Node.js path AC goal, because we're building a hockey goal light. Successfully generated boilerplate, that's great. So then I'm going to cd into AC goal here, and I'm going to open this in my favorite editor. So let's take a look at what's going on in here. So serverless has basically just stubbed out a small application for us. Doesn't look like there's a lot of stuff in here. We have this serverless YAML file. This is where this is where you basically configure what you want, what events you want Lambda to listen to. You can see there's a lot of this commented out code here, including some different events, users create, how to use variables. So there's a lot that they give you, and the documentation is really great. This is one of the best parts about using this framework, is it's really easy and kind of fun to get started. So let's talk about what's going on here. So the provider is name AWS, the runtime is Node 4.3, and I'm going to add my credentials in here by passing in profile serverless admin, and that is set. This is where I set this in this file here, AWS/credentials. So if I open that in a text editor, you'd be able to see the credentials for that serverless admin, but I'm going to not do that so you don't see. And then here in handler, you can see that we just have this module.exports.hello, and this is in handler.js file. So that maps down here directly to our hello function. And then we have a hello function, and we tell it the handler that we want to use when this function is invoked. And a function is basically a Lambda function, AWS Lambda function. So these two names don't need to be the same, but let's keep them the same going forward. So what we want to do is let's start by changing some of this around. Let's call this goal. Let's save that. This would break right now, so let's make sure we update handler.goal. And to keep things consistent, I'll say goal here. All right, great. And inside of the handler file, what I'm also going to do here is I'm going to paste this line in. It's just some notes I like. So I like to add this here just for my own notes. Right now, context.callback waits for empty loop is always set to true. I just like to be a bit verbose about it. And so I make sure to paste this into my handler file right away. What this essentially is saying is that the way this function works is it accepts 3 arguments: the event, the context, and then the callback. And whenever you invoke this function, the event has to do with the details of what triggered the event itself. In our case, we'll be using an HTTP request, and that request will have a body. So that will expose an event.body. If this was a GET request, then it would expose an event.queryString parameters object that you can use. There's a bunch of other stuff, and we're going to take a look at what that looks like right here in just a second. It also has this context object, and so this context argument or object comes from AWS, and we're able to update information about it. This is like how much time has the function been running for, how much time is left in the function before it gets cut off, because you can set a cutoff for these functions so they don't run on forever and you accidentally get billed forever. So these are by default are set to cut off after 6 seconds. The server essentially the container will get frozen and destroyed. And so you can ask for things like how much time is left before the container is destroyed, that type of information. But one of these that's pretty important is callback waits for empty loop. What this means is that as soon as you fire this callback call, do you want to destroy the container? And if this is set to false, it does not wait for empty loop. What this means is as soon as this callback function is fired, then the container would destroy itself. In our case, we are going to want to call response right away. We're going to want to send a response right away. We're going to say everything looks good from your end, and now we're going to do some work. And that work is going to be flashing the LED. So we actually want to make sure that the callback does wait for an empty loop so that we can use nested callbacks or promises or whatever we need to do here in this JavaScript file. So great. So let's continue on our journey here. So I'm going to throw in a little bit more information here. For the sake of time, I'm copying and pasting from off screen. So what I'm going to add in here is I'm going to just log the event.body, and the context object so we can take a closer look at it and you can see what I'm talking about. And the next thing that we need to do is hop back into this serverless.yaml file, and we need to give this function some events. So you can see this is kind of stubbed out here. You can copy and paste this or uncomment out the file. It's not a bad idea so that you can get the formatting right. So let's see. Make sure everything is lined up. Path, we're going to call this AC/goal, and we're going to method is going to be post. Okay, so all of that looks pretty good. And so now what we can do is that's it. We can actually this is ready to deploy and start inspecting right now. So we're going to call serverless deploy, and we'll call this from the folder that we're in. What serverless will do is essentially what it's doing is it's turning our YAML file into a CloudFormation file right now, and it's uploading that information to AWS, and then AWS is going to provision the products and features like API Gateway and the Lambda function based on this handler.js file. So once we do that, serverless will spit back out this URL. So what we'll do here is we'll take a look at this URL. So we said we were going to send a post. So let's paste it in here. And we send it, and you can see we got this response. So here's our message. I'm using Postman to do this. You could use curl if you prefer a command line flavor, but you can see here it says go serverless v1, your function executed successfully. This matches, here we go, the message that we pasted right here. And then here's the input. We have input, and you can see here's the entire event object that we sent in here. So let's make this form encoded to match what is going to come out of ActiveCampaign when it's ready. And let's say greeting, let's call it hello world, and send it again. And here you can see body, here's greeting equals hello world. And we can also look at this in some other places as well. So let me bring up AWS. So we have those console.log calls. So if you take a look right here, we have event equals JSON stringify body, event.body.body, and context. So we're passing all of these in here. Oops, I'm sorry. So let's take a look at where that's going. So we'll come in here and we'll choose CloudWatch. You can search for CloudWatch. And here's where you can keep an eye on things. If you come down to logs, you can here see that we have AC goal, dev goal. The second dev is the stage that we're on. And then we can come in here to the most recent request, and we can see, so here it says event equals resource, and here's the whole event. The second console.log, for the first request we made, we didn't pass any body parameters, so that comes back null. And then here we have some information about the context, so you can take a closer look at what type of information you have access to there. So here's our second one, and here you can see the body is greeting hello world, and here you can see that the entire event, here's the body equals hello world. So you can take a look at the rest of this information. This is good stuff if you want to limit who can send you information. You can also provision API keys. You can do a lot of stuff with just basically an empty call. We're not going to be covering that right now. I just kind of want to make sure that you're aware of how to kind of debug these lambdas. And I'm not going to be covering stages right now just because this is a dinky thing for fun. But once you get used to it and you dig a little bit deeper, you can play around with the stages in there. So I'm going to minimize this for right now. I'm going to minimize this for right now. So now we're up and running right there. So the next thing we need to do is open up we need to add some NPM libraries, and maybe here's a good place to stop and look at what we're actually building here. So I have already created the particle device, which is right here, and the light that we're going to be flashing. I'll give you a link so that you can download this code. This is very easy. I think it's like 40 lines or less of code, very easy to use, and you just follow along with the tutorial on the page. What's happening here is we've got a particle device. It's connected to a relay here, and there's 4 relays here, and each one of these relays is connected to a digital pin on the particle board, which is like an Arduino, and then that's connected to this flashing light, which is plugged in. And so the way the whole thing works is I have this particle cloud function is what it's called, representing this device ID. And so what I can do is I can hit that with a post request and the light will flash. And I wrote the code a little bit so we can send in this seconds parameter. So if you want to pass in 1 second, flashes for 1 second. If you want to put in 5 seconds, it'll flash for 5 seconds, depending on the size of the deal. So what our goal is now is to hit this endpoint from Lambda, and we need to transform that request. So what we need to do then is we need to kind of level up our little repo here. I'm just going to stick with the defaults. So I'm npm init so that we can save npm files. But when you upload this package to AWS, everything will go with it. Everything in this serverless file will get zipped and sent up to AWS. And so that includes that the node modules library will also get zipped up and sent. So what I can do is I can do npm install save request, which is the request library that we will be using to make the post request from AWS Lambda. And then, so we're in good shape there. And then we just need to include the library. And I'm also including a little bit of particle details here about my specific photon, the base URL, and the access token here. So I need to grab those from a different place. So I have them saved in my Postman environment here. So Ray the plant, that was the original name. So I'm going to grab the device ID for Ray, and this dummy access token I created for this tutorial in case you guys see it. So then I'm going to cancel that out there. So now we're creating this Ray object with a device ID, base URL, and an access token, and then we're also importing the request object. So we're in good shape there. And the next thing we need to do is we need to build the request string here that we are going to use to hit the endpoint. So I'm going to comment those lines of code out, and I'm going to paste in this request string here. So what are we doing? So we're taking the base URL from here, https api.particle.io, and then this is the default route to create what is called a particle cloud function. And then I'm taking the device ID here and adding goal to the end. And that's where our device function goal lives. And then I'm going to use the request library here to build the actual request. So I'm also going to do a little bit of reorganizing here. So I'm going to move this up higher in this file, because essentially what we want to do is we want to let whoever is making this request know all is well. All right, that's good. And let's examine what is happening here. So here we're calling a request, which we set up here, which we're importing with the npm library. And we're making a post request using the request string that we created right here. And we want it to be in the type of a form. And this is like a form URL encoded regular thing. And then we're going to set our access token. This is what we have defined up here. This is just has to do with the way that Particle accepts these requests. And then we're going to pass in how long we want the light to blink for whenever a successful request is made. So essentially what this does is this hits the same that we were doing with Postman, the same endpoint, Particle endpoint that we were using in Postman right here. This one right here, goal. So this /goal endpoint, you can see in the body here, we have access token. So we're going to hit that from our Lambda function whenever this Lambda function gets a request, which seems kind of silly, but we need to transform the data before we send it on to blink the light, because we need to make sure that we are only flashing the light on deal 1 and not on a deal lost or anything like that. So great. So we are in a good place here to do check, make sure everything is working okay. I'm gonna bring console log up. I'm gonna delete my past log files so that I'm clear here. And we'll wait for this to finish. What we're gonna do when it's finished is we're gonna hit this with that post request again. So this time we're going to be hitting AWS with the post request instead of hitting the LAMP or the goal directly. So here's the URL. And the reason we're doing this is because we want to take a look at the logs. So sure enough, it worked. The light is blinking. We were able to hit that endpoint. And if we come in here to AWS, we can take a look. We have a new log stream here, which is good. That's what we want. We have the start of the request, and it looks like we're still logging out some details, and you can see that it says something good happened. This is what we like. This is coming back from the request callback console.log, something good happened, and we should expect to see the response that came back from Particle here in a second. So here Particle sent us a little bit of information, basically that it includes in every file. So far, all we're doing is basically just proxying these post requests through our API that we created to the Lantern, which is good. And now we could add our own layer of security or whatever we wanted to do on top of this. If we wanted to do API keys or whatever, we could handle all of that in AWS instead of depending on Particle. If we wanted to just stop there, but we don't. So the next thing we need to do is we need to take a look at basically these webhooks, the webhooks that are coming out of ActiveCampaign when a deal is won. And so I know some of the answers and I will tell you about them. But first we need some libraries. So I'm going to do install save query string here. So that's going to install query string. Then I'm going to come up here, const query string require query string. Okay, so we added const query string equals require query string here. And what we're going to do here is, this looks like a good spot. So we're going to use query string and we're going to let webhook body equals query string dot parse event body, so that this is something that's a little bit more usable. And then let's log this out to AWS. So stringify, and then we'll call this webhook body. So there. So now what we're going to do is we're going to do the exact same thing as before, only this time we're going to send a test webhook from ActiveCampaign instead, and we are going to log this out here. So I'm going to let me see. I'm going to turn some of these off so that we can take a better look at what's going on its own. Okay. So let's deploy this. And let me bring up an ActiveCampaign account. And ActiveCampaign is pretty cool. One of my favorite features about the platform is that it has all of these webhooks when things happen. So you can come down here to manage webhooks, and let's create a new webhook here. And we can create a webhook whenever a campaign is forwarded, an email campaign is open, shared, all kinds of stuff here. And so what we're going to do is we're going to take the URL we've been using, because it'll be deployed to the same URL here, and we'll post it into the URL, and then we'll give it a name, ring the alarm, and we want this to happen whenever a deal is updated. And then we want to fire this webhook whenever a contact updates the deal, an admin user updates the deal, or the system itself, like an automation, updates the deal. But first, we're going to send some sample data. So we got this green notification at the top. That means we got a 200 code back from our API. Let's refresh the logs. Here we've got our logs, and let's look at what QueryString is doing for us here. So here's the payload. Here's what the payload it comes out of ActiveCampaign looks like. And I'm gonna cheat a little bit, and I'm looking for status here, deal status 2. So I happen to know what deal status, there's 3 numbers, it's 0, 1, and 2. 0 means it's an open deal, 1 means it's a won deal, and 2 means that it's a closed deal. So what we want to check for is we want to make sure to check that deal status equals 2. So let's turn this back on, but let's wrap it in an if. Webhook body. And then what are we looking for here? I'm just going to copy this here, put that in there, equals 1. Then we're going to make our request. We only want to make a request if deal status is 1. Great, so we got this in here. And otherwise, we don't want to do anything, but we'll just let the function die. Okay. And so now I think we are all set here. We're going to deploy this final version up to AWS. And what's happening now is when a deal gets marked as won in ActiveCampaign, ActiveCampaign sends a webhook to our API that we just provisioned, built, is ready to scale infinitely, and we could very quickly and probably in the rest of the afternoon harden with API keys and rate limiting and any other number of pretty cool features. We've gotten all of this done in about 40 minutes. We're routing that through this IoT device using Particle.io to flash this light whenever a deal is marked as won. And so I think that that's everything we need to do. So let's come in here to the Deals tab. Oh, you know what? I need to make sure to save that. Save that. So let's grab this again. Deal updated. Sorry about that. Ring the alarm. And we want this by contact, admin user, and system process. So we'll add that. Okay, great. So now we can go back into deals. Let's create a new deal. Just going to put in my email address. All right, no blinking yet. Let's move stages. No blinking yet. And now let's mark the deal as 1. The light goes off, and we have successfully created a device that will motivate the sales team. Problem is, I showed this to them, and the first thing they asked is, will it make noise? So stay tuned for another lecture about how we can have it make noise. Other than that, feel free to follow me on Twitter or whatever. I'll be around to answer your questions right now. Afterwards, that was a lot. I'm going to make sure that you have the slides, the code for the particle, a parts list for the particle, including the flashing light, and the code for the completed code here for serverless and links to the serverless docs. So I think that's it for this lesson, and let's take a few questions.